Okay, this is optimization problems number 1. So this is kind of fun because we get to apply our skills with derivatives in these problems. A piece of cardboard measuring 10 inches by 8 inches is formed into an open top box by cutting squares with side lengths x from each corner of the and folding up the side. So essentially we have this kind of a shape. And it's not drawn to scale. And they cut out corners. And so when you fold up the rest of this, you end up with a shape that looks something like this. Okay. Now in this shape, this height is x for all these there. Now what's left? So if this part is x and this is x and this is x and this is x, this part inside is 10 minus 2x. So here we have 10 minus 2x. And then this part would be 8 minus 2x. So we have 8 minus 2x. So our volume of the box would be x times 10 minus 2x times 8 minus 2x. I'm going to switch to blue because I prefer blue. Okay. And we're supposed to, for part B, and that's what we have here. For part B, we're supposed to find the value of x that will maximize the volume of the box. Now, 8 wouldn't work because 8's 2 times 8 is 16. It's going to be bigger than either side, so we can't cut that much out. Now, for me, it'd be easier if I just call this v of x equals, and I'm going to multiply this out. So I'm going to call this x times 80, I'm going to FOIL it, minus 20x minus 16x plus 4x squared, or v of x equals x times, excuse me, 80 minus 36x plus 4x squared. And v of x would be 4x cubed minus 36x squared plus 80x. And I just noticed that we could divide everything by 4. Maybe I'll skip that. I won't do that yet because I don't want to, that's not going to be a problem. I just don't want to mess some things up with understanding of what's going on. Okay, so to find the maximum, so this shape, this is a cubic, so it's going to look something like this. So we want to find that maximum value. So we're going to take the derivative. That's where the slope is 0. It'll be here or here. So where the slope is going to be 0, we want the bigger one. Where the slope is 0 is going to give us either a maximum or minimum here. So v prime of x is 8x squared. Nope, not 8x. 12, everyone correct me, 12x squared minus 72x plus 80. Now we could divide out of each of these. Oh, sorry, I'm skipping a step. So we're going to set that equal to 0. Now if I divide a 4 out of everything, I'd have 3x squared minus, and what is 4 into 72? Is that 18? Yeah. 18x plus 20 equals 0. And I'm not going to fight with trying to factor that. I think I'll just go to the quadratic formula. I mean, this might be factorable. Thinking the factors of 20 that add to be 18. But given that I happen to have a glimpse of the answer, I'm just going to go ahead and use the quadratic formula. So x would be negative of negative 18 plus or minus the square root of negative 18 squared minus 4 times 3 times 20 all over 2 times 3. So it's negative 18 plus or minus the square root of, and 18 squared, and my handy dandy calculator is charging. So let's pull on here. Handy dandy computer, 18 times 18. I should know this one. It's like 324. So we have 324 minus 4 times 3 times 20. So wouldn't it be 240? All over 6. So it's negative 18 plus or minus the square root of. Square root of 84. All divided by 6. Oh, there's a double negative. I forgot that's a positive now. Like, starting to have a little panic here. I'm like, we're going to have a problem. Okay. So we will have 18 plus, and what is the square root of 84? We know it's more than 9. So let's do my square root button. There it is. 9.16515 divided by 6, or 18 minus 9.16515 divided by 6. So in the first case, so I'm going to add 18 and then divide by 6, and I have 4.527. Is that reasonable? We'll call it 28. Is that a reasonable number? If we come back up here, could x be 4.25? Well, that's going to make it longer than this side. So that's not a viable answer. So let's look at the other answer. And we would have 18 minus 9.16515. And then we divide that by 6 to get 1.47245. And this is, there's going to be some round off error here because I did not carry numbers through very far. And that's the answer that we have. So that's the more reasonable answer. It's going to fit within the parameters for each side. So I hope that helps.